This screencast is about atoms, ions, and isotopes. Let's get started with comparing these. A quick review on atomic structure. Recall that atoms are neutral, meaning that they have an equal number of electrons and protons. The atomic number indicates the number of protons in the nucleus. In our example here on the right, there are 8 protons, which means that this is an atom of oxygen. We know that because the atomic number identifies the element. The mass number is the sum of the protons and the neutrons. To calculate the number of neutrons in an atom, what you're going to do is round the mass number to a whole number, and then subtract the number of protons. Let's practice that here. Here we see a tile from the periodic table for the element potassium. Notice that the atomic number is 19, and the mass number is 39.10. That means that this atom will have 19 protons and 19 electrons. To determine the number of neutrons, we round the mass number 39.10 to a whole number, or 39, and then we subtract the number of protons, 19, giving us a total of 20 neutrons in the nucleus. So our atom of potassium will look like this. Notice that there are in fact 19 protons in the nucleus as well as 20 neutrons. The electrons are outside the nucleus on the energy levels. Note that there are 2 electrons on the first energy level, up to 8 electrons on the second, up to 18 electrons on the third, and up to 32 electrons on the fourth energy level. Let's compare a neutral atom to an isotope. Isotopes have the same number of protons, but a different number of neutrons. Most elements on the periodic table are isotopes, and this is going to explain why the mass number on the periodic table is a decimal, but we'll get to that in a future screencast. You can think of isotopes kind of like a car model. There's a base package for a car, but then there are models that add different frills, different upgrades. Okay, so for example, I drive a Dodge Durango, and Dodge Durango comes in several models. There's the SXT, the SXT Plus, a Limited, an RT, and a Citadel. Again, each model has the same base package, but then those special features are different. The same is true for an isotope. Each isotope of an atom has the same number of protons and the same number of electrons, but what's different is the number of neutrons. What I want you to know right now is that the most abundant isotope is the one with a mass closest to the mass number on the periodic table. For example, if we look at the periodic table, carbon has a mass of 12.01. That means that the isotope carbon-12 is the most abundant. We can indicate which isotope we are working with using either hyphenated notation or nuclear notation. Hyphenated notation is where you write the name of the element, or the symbol, followed by the mass number for that particular isotope. On the right side of your screen, you'll note that carbon-14 has a mass of 14, carbon-13 has a mass of 13, and carbon-12 has a mass of 12. We can also indicate which isotope we are working with using nuclear notation. In this case, we write the symbol for the element, and to the left, as a superscript, or on top, we write the mass number for that particular isotope, and to the left at the bottom, or as a subscript, we write the atomic number for that isotope. Let's take a look at some isotopes of carbon. In the picture on the far left, notice that this is carbon-12. This isotope of carbon has 6 protons, 6 neutrons, and 6 electrons. In the middle, we have an isotope of carbon-13. This isotope of carbon has 6 protons, 7 neutrons, and 6 electrons. And on the far right, we have an example of carbon-14. This isotope of carbon has 6 protons, 8 neutrons, and 6 electrons. Notice that in all 3 pictures, the number of protons remains the same, and the number of electrons remains the same. The only difference in an isotope is the number of neutrons, which changes the atomic mass. Let's practice calculating the subatomic particles in an atom using nuclear notation. Pause the video and determine the number of protons, electrons, and neutrons in chlorine-35 and krypton-84. When you've finished, restart the video and watch the information about ions. Ions are atoms that carry a charge because they have a different number of electrons. Ions can be positive, and when they're positive, they're called cations. Positive ions happen because electrons were lost. Ions can also be negative, and in this case, they're called anions. Anions are formed because electrons were gained. To help you remember this vocabulary, especially cations, think of an old Tom and Jerry cartoon. Whenever the cat would be hit on the head with a frying pan or a baseball bat or anything else, he would always get X's in his eyes. Turn those X's on its side and you've got a plus sign in the cat's eyes. So the cat ion is positive. Here's an example of how a cation is formed. This picture is a sample of calcium. Notice that in calcium there are 20 protons, 20 electrons, and 20 neutrons, and our symbol is Ca. To form a cation, we remove those 2 electrons on the outer energy level, so our ion will look like this. This ion of calcium has 20 protons, 18 electrons, and 20 neutrons. Because there are 2 less electrons than protons, our symbol will be Ca plus 2, or Ca2+. When we write an ion symbol, we always want to include the charge, positive or negative, and the degree of that charge, 1, 2, or 3. Let's look at another example, this time of an anion. On the left, you see an atom of oxygen. This atom has 8 protons, 8 electrons, and 8 neutrons. The symbol is O. On the right is a diagram of the ion of oxygen. Notice the 2 extra electrons in the outer energy level. They're shaded purple. In this ion, we have 8 protons, 10 electrons, and 8 neutrons. Because there are 2 more electrons than protons, that gives our ion a charge of -2. So our symbol is O-2 or O2-. Add these practice problems to the practice problems for isotopes. In the first part, I want you to identify the number of electrons in aluminum +3, bromine -1, magnesium +2, and phosphorus -3. Remember, if you have a +1 charge, that means you lost 1 electron. And if you have a -2 charge, it means you gained 2 electrons. So the charge and what happens with the electrons are opposite. After you finish that, I'd like you to write the symbols for the following: an atom of sodium with 10 electrons, an atom of chlorine with 18 electrons, an atom of beryllium with 3 electrons, and an atom of sulfur with 18 electrons. Remember, to write the symbol for an ion, you have to include the charge, plus or minus, and the degree of the charge, 1, 2, or 3. When you've finished with these notes, take a picture of your answers to the problems and upload them in Schoology.